Hello guys, today we're going to be presenting our project Lunar Exploration Rover. It consists of four-wheel driving, a platform with FPV camera system and being able to control it with just one app. So let's go over our team. Our team worked on mechanical design, chassis construction and electrical engineering is me, Rushil and Ayan. And I also chipped in firmware development, mobile app and system testing, which is also done by Anika and Rushil.
This is Shalom Savio Pereira and this is Vivek.
So our problem statement.
In case you're wondering why we're building a lunar rover,
Help lunar missions which demand robotic systems capable of navigating uncharted area such as the moon.
Astronauts going to the moon has become another feat of humanity throughout these coming years, and the actual understanding of interplanetary surfaces and all needs to be done. This exploration can only be done via the collection of certain samples on the moon or certain samples on surfaces anywhere. And so one of the first steps is to create an organized sort of manner to collect that. Now, if you were to ask why don't astronauts pick up moon rocks with their hands, well, there's a lack of mobility, it's not careful enough, and the actual regolith of the moon is very brittle, can be controlled properly. So to solve all of this, plus to also maneuver through the extreme conditions of the moon, rovers have been used as the primary source of this collection and extraction of this information.
So we have a six-wheel mobility chassis, which is flexible to adapt to the abrasive terrain on the space. And then we have an excavation mechanism, the electronic components, and of course 2 bases to provide support and be stable.
So we have a navigation camera, like an ESP32.
this is the navigation camera in case
Right here, this thing. And we 3D printed a case for it to keep it like safe, because it's like one of the vital parts
and to keep it standing.
Yeah. To keep it standing, it's one of the vital parts of our rover. So using Omni wheels, we can since the camera can't move like their rover, we use Omni wheels to turn in place so that we can avoid any obstacles, because normal rovers, they turn in an arc. We can spin in place, which is a way faster way to turn. And we used an IR remote connection because we thought it was more convenient to always have the remote in your hands and control it.
Honestly speaking, the design of our lunar rover, as you can see, it has 6 wheels. The chassis has 6 wheels, 3 on each side, to provide a suitable balance, as well as a longer wheelbase. And the longer wheelbase with the proportional angle of the chassis helps for stability, control, and even going up and down, can say, whether small or large size boulders, or even
this is
up and
from
down.
blueprint to prototype. It's like starting a research and then conducting the prototype by engineers or green.
See this in 3 gears, you see.
As you can see over here, the middle picture is what portrays the rocker bogie system. And the rocker bogie system can say the front 2 tires are linked to one hinge, while the back is a sole independent stroke.
So for this to work and for our project areas to be able to be energy efficient and also collect regolith, the hardware components that we use is at the front. We use the micro servo to control our ultrasonic, and although ultrasonic does not work on in vacuum, we decided to just have this in our prototype so we can test it out here on Earth and still simulated lunar excavation simulations. We also use the micro servo at the back, and we out on our rear mounted excavator, which is more like a dump truck kind of mechanism, where we will use the micro servo goes from 0 to 180 degrees in this prototype at least, and it collects the regolith into our bucket. And then we used our DC motors and for our 6-wheel chassis to make sure that for stability, and we also divided all the weight and all the components equally, so our six-wheel chassis is stable enough. Even though we faced a few problems for it, we were able to solve those. And then we have an ultrasonic sensor at the front that will be able to detect all the obstacles that we could face on the moonway, for example.
Okay, so
And,
for mechanical design, we used a chassis, which is a flat modular 3D printed frame. So basically, this one has a lower center of gravity so that it's more balanced. For the drive terrain, we have 4 N20 motors attached to the deep threaded wheels. This offers better traction and it increases the torque. So for steering mounts, we have independent servo motors attached to each of the wheels so that it contains a full 360-degree steering range. The electronics deck is basically the upper deck we have with all the organized electronic instruments like the ESP32, the drivers, and the camera.
And here is the circuit program.
So this is our circuit. Our circuit designer. So the Arduino microcontroller is the central processing unit. We thought like the Arduino Nano would be like a step down from the Arduino Uno because obviously this can hold more it's faster, it's a faster processor. So that's why we chose this instead of an Arduino Nano. And we used an IR remote control for immediate, precise manual operation and testing. And we used the gyro motors to ensure robust and reliable mobility across lunar surfaces, and the power system for efficient battery management for extended operational periods.
Not to mention, our circuits are placed in this middle layer.
So the key electronics that we have used in this rover are Arduino, the motor driver, a battery system, and a breadboard.
Along with the regulator as well, just to
A regulator for voltage purposes. The languages we have used in the process of building our rover is C++ in the format through Arduino IDE, which is a coding language that we had to learn ourselves and coded the actual movements of the rover, the motors, and the gripper itself.
Use the ESP32 firmware to control everything, to control the motors, the servos, the LEDs, and the Bluetooth. And it sends out single character signals like L, P, R, etc. and angle-based camera instructions. We also built an Android app using MIT App Inventor to control all of the servos on the entire lunar rover, including the ones on the camera, to turn it left and right.
So obviously,
And-
any prototype at the beginning, especially at its first stage, it has its strengths and has its limitations. So in ours, our strengths is the integrated design in the way we have a six-wheel chassis, and we use it for stability. We use electronics, we use sensing, we use a wireless control and Bluetooth. But moving into the limitations is that when we're at the moon, we cannot sit here and we cannot control it through Bluetooth. So that's our limitation, and that's what we want to improve on if onto another prototype.
So our strengths are the cramp steering and our live streaming using the FPV feedback and the 2 degrees of rotation. We have a modular 3D printable design which creates a low-cost solution and easily replaceable if there are broken parts, and it's expandable if you want to add automation or sensors. So the limitations are the fact that it doesn't have any autonomous navigation.
Scenario, what would be the additional things we would add onto this rover if we got the chance?
And it's a modular design, so it allows for easy upgrades and customization for various lunar tasks. Common tasks include exploration of the moon, but since it has omniwheels, it does in all 4 directions, since the camera is single-sided. Another one is its cost-effective prototyping, which is utilized using readily available components like Arduino 3D printing. You see, it's made out of way less materials, and it's programmed less compared to other programs, which is why it's low cost. And scalable technology concepts can be scaled up for larger, more complex sections. The most common material for 3D printing is polylactic polymer.
So after this is the first prototype. We'll also include AI integration, so we don't have to manually control it, which would help, but it could also make us face some obstacles because there might be unknown substances on the moon which AI might not be able to
We
navigate.
have to train AI to navigate unknown planets and unknown terrain. So
In the altered tires, we might also add a certain system similar to the actual NASA adaptable tires that are used in rovers currently, which consists of this memory sort of spring system such that when the tires are actually pressed, they come back to their original form, they are airless and they are extremely heat and cold resistant. So
Developing a reliable control system that combines remote operation with sensor assisted navigation. And then evaluate the rover's performance, including navigation efficiency, duration, completion time, obstacle response, regolith collection, energy consumption, like energy efficiency.
one of them would include heat regulation. Obviously, with any complex circuitry, any complex processing, whether be it a gaming PC or something as a lunar rover, there will be a lot of heat created within the actual circuit boards. And from recent research, actually, through a lot of essays, diamonds have been a really good source of dissipation and actual heat conduction out of the actual circuitry. So if we were to build out the model itself as a life-size version or a much more scaled up version, we would add these diamonds to allow heat dissipation. Number two, ease and customizability alongside AI basically means this rover, we would consider it to be an all size fits all sort of solution, basically allowing different attachments, different components to be added along with it, so that it doesn't just get stuffed up into a little box, right? Where this is only used for this.